Hi, sorry. Hi, tech enthusiasts. Grab your coffee and let's start another day with an interesting coding problem. You ready? I am. So, yesterday I solved diameter problem with diameter, yes? No? Sorry, external link. I forgot which one I solved, which not. I solved depth, I solved diameter. At least I remember it. Yeah. So here today it should be balanced binary tree. Given a binary tree, determine if it's height balanced. What is height balanced? We have hint. Height balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than one. So this one is balanced. This one is balanced. Not balanced because the left subtree's height is 3 and the right is 1. Also the empty tree is balanced too. Let's try to solve it. So we can calculate height of subtree for each sub again. I need to calculate height of left and right subtree, compare them, and if no, again, I need to calculate height of left and right subtrees for each node. For one, for this one, etc. After it, when each height is calculated, heights of subtrees for each node is calculated, I can traverse through tree and compare heights. If a height in any of node for any of node differs more than 1, then we can I can interrupt the process and return false. If not, I can do it until I check until I check each node, and if I won't find any node which is unbalanced, then I return true. Probably I don't need to calculate. Yes, definitely, not probably. I don't need to calculate each node's height, because if, for example, height of the first node is differs more than 1, left subtree's height is 3 and right height is 1, so I can return false on first node, on the root actually. So let's do something. Let's try to do something. Something like that. If not root, return true. Probably I don't need it. It depends on approach. Then what I can do, I can make something like that. Return is unbalanced. No, is balanced root. That's it. Is balanced root. It's not okay. What can I do? I don't want to use recursion here, so I need to use approach with queue or stack. Probably with queue. Something like so I have queue, it's empty, it has a root, then while queue length what we do, we go through each of item in queue and do something. After and calculate something, and while in this process I need to push to the queue subtrees of each node on current level. For less than your length, I etc. Also I need to remember queue length, initial length, because it will be changed while I going through queue. So we go through the items, we do something and repeat it. Var is not balanced, something like this, probably. So what we do, we shift or pop, no, we shift. I need to remember. And then what do shift? First element of an array, yeah. So we, what I do, current q shift. So we have current, not current, let's name it node. We have node, no, I can't use it like this. I need it will, I need recursion here. I can't imagine how can I solve it with Q, because I need, if I use Q, I need to calculate one at first iteration each node's height, and I will need the second iteration. Okay, let's do it with recursion. So with recursion I can have some callback function node. I do something in this callback and I traverse root callback. Probably I can return, and it is it. We guess that it's balanced initially. True. I don't know yet what I can do in callback, but function traverse node callback balanced true. So if no node return true. I need the height of current. Initial height is 0. Return its height. After it, what can I do? It reminds me yesterday's problem. I go the same. I go to the same solution. So what I don't remember actually how I solved it. I remember something like var left height I need and how can I calculate left height? Traverse node left, call back, height, and true. I don't know. Right height. If it is or no. So I calculate, I recursively go through each node. First node, I had its value, but I don't need actually its value. I just need to calculate its left subtree height and right subtree height. Yes, left height, right height, I have it. Then I can pass left height and right height to my callback. Callback node left height, right height. If callback is false, we stop. So I don't need balanced flag. It would be used outside. So I don't need this flag. And how can I solve it when I got here, and if is not null, then it should return height plus 1. Return like this. If no node, we return height, because this node is not increased. Otherwise, we return height is 0 initially. We init it with left height, right height. Yes, probably it should work. Var is balanced flag, true. Function node left height, right height. If abs left height minus right height more than 1, balanced flag false, return false, return true, and that's it. Wrong answer, but in the first case it's right answer. Output true, but should be false. 1 2 2 3 3 null 4 4. I don't need to return traverse result. I need to return balanced flag. And it still is not correct. Let's watch an description again. Never differs by more than 1. Never differs by more than 1. So it could differ by 1. But it is more than 1, definitely, and so it is false, return false, callback let's return height here, height plus 1. I don't like that I plus height in the end. I can return it like this. If we don't have the tree, then our height will be -1, but it's okay. But I can do it like this. Yeah. Probably it should it help. No, the back is somewhere. Back is somewhere else, elsewhere. So, is it working? Let's try. Console log. Node value and height. Let's watch what we will see in console log. 1 height is 0, 2 height is 1. Wow. 2 height is 1. Yes. 2. Why I don't get 2. Yes, 2 height is 1. I was wrong. I got correct height on the last node, not on the first. Yes. because for example, for right side, right height, so we have node. Initially its root, its height is 0. So if we have node, we calculate its right height. Oh my god, right, horrible. Yeah, it's still wrong. Hi. R-H-G-A-T. R-H-G-A-T. H-I-G-A-I-T. Okay, let's watch the height of this side of right subtree is 1. So for this node, height would be 2. It try to calculate its and what is the height? Yeah. I missed something. Height is the max between right and left. For node itself, its height is the max between right and left. Yeah. Max between left height and right height. If it's not callback, then we just interrupt with nothing. Yeah, it works now. So basically what we do here. So if we don't have node, then we reduce its height because it don't increase the height. Then we calculate right and left height, right subtree and left subtree's heights, call the callback, and if it's falsy, then we stop traversing. After it, we return the node's height, and the node's height is the max between left and right subtree. Let's try to submit it. Yeah, it works. It's not good as of performance. Probably I can't solve it with Q, and it should be more efficient. I need to just realize how can I do it with Q. The same I have while Q length var queue length is queue length for I0 I less than queue length I increased by 1 do something. So we have balanced flag, it's true by default. Also I need to calculate height, but height is the same for each. No, I give up. I need to watch solutions. Let's watch this first one. What is approach? Return true if height root -1, return false. Height, left height, right height. If max, yeah, it is recursion. Java, C++, Python, JavaScript. Yeah, it is the same. Iterative. Do we have iterative approach or queue? Yeah. Sorry. C++ level order approach. Interesting. Yeah, with queue. We have queue. While queue is not empty, queue size 4. Queue front. We have current. Is balance car more than 1? What is balance? Calculate left and right height. Height is one plus max height of left and right. Wow, it's not okay because you calculate height again and again. Let's watch JavaScript solutions. Wow. Iterative plus memoized solution. ON, wow. Get height. Where is the JavaScript solution? Okay. Is balanced root. If it's not root, return true. Okay, root while queue is not empty. Left, right, height. If current left, we increase. We calculate height of the left side and calculate height of the right subtree. If difference between them more than 1, return false. Otherwise return true after whole cycle. Get height. If node in memo, so we can use this approach. Let's try to copy it. So this here is the difference. Var left height 0, var right height is 0. If also it should be it's nothing for, it just, and we don't need the length of the queue. Yeah. If, oh sorry, I need current. Var node is queue shift. If node left height is get height node left. Queue push node left. If node right height get height of node right, and queue push node after it. If math abs left height minus right height more than 1, return false, return true. That's it. Also, I need guarded. If not root, return true, because we couldn't push empty nodes to our queue. Here I need function get height node of node, yeah. And just let's copy memoized get height method. What can I have here? Memo. We have memo structure. Memo new hash new map. memo has our node, return memo get value for our node. If not, if what means if not? It couldn't be null because we prevented. Yeah, and we don't push empty nodes to here. Okay, let's skip it. Let's move to the next. Memo set node and value. Return memo get node. Something like that. 1 plus math max get height of node. Aha, it could have get height node, right. Memo so we set for now we calculate height. Yeah, so I need this guard. If and also I need to do it here. If not node memo set no, I don't need set something. I just return 0. Let's try to run it. Wow, it works. Let's try to submit it. It's accepted. I thought it would be more efficient, but it is horrible. If someone knows why, you can write it. But probably because I use additional structure map which is consume additional memory. I'm not sure. So what's next? Nothing next. That's a solve. Yeah. I hope you found today's session helpful. Comment your thoughts in the comment section and see you in the next video.